Here we have a problem in integration, that is we have to find the indefinite integral over here. Okay, let me start working on this. In my first step, I am moving this constant 3 out of the integral. Then I'm getting 3 times integral 1 over 1 positive 25 x square times dx. So equals to 30 times 1 over 1 positive. I can write this 25 as 5 square. Then we have x square dx equals to 30 times integral 1 over 1 positive. So here we have square for both 5 and x, and both of them are multiplied. Whenever two terms are multiplied with the same exponent, we can write the exponent in common. Then I'm getting 5x whole square times dx. And also for this one, I can consider square. Even if I take square for this one, it's still equal to 1. Now let me consider a particular formula in integration, that is integral 1 over a square positive x square times dx. So it results 1 over a times r tan, let me write the stuff over here, r tan x over a positive c. Okay, so here when I consider the integrand, this is almost in this form of 1 over a square positive x square. At the place of a square, we have 1 square. But at the place of x square, we have 5x whole square. If I want to use the formula I have explained over here, so here a single variable has to be squared. But in our problem, a variable is multiplied by the constant 5 and it is squared. So at the place of 5x, I need single variable so that I'll be able to use this formula. So for that, what I'm going to do is I'm going to do u substitution. That is, I'm going to substitute a new variable u for this 5x. Okay, let me do it. Let u equals to 5x. Since I have substituted a new variable u for this 5x, I have to get this complete integration in terms of the new variable u. When I get the complete integration in terms of the new variable u, at the place of dx, I must have du. For that, what I have to do is I have to find derivative of this u. Since we have the original integration with respect to the variable x, now I'm going to find derivative on both sides of this equation with respect to x. When I find derivative of this u with respect to x, I'm getting du over dx. And here 5 is a constant multiplied by the variable. When I find derivative, if there is a constant multiplied by the variable, I have to keep the constant as it is. When I find derivative of this x with respect to x, it will become 1. Okay, now to get of the dx in denominator, I multiply both sides of this equation by dx. When I do so, this dx will cancel out. I am getting du equals to 5 times 1 is 5, 5 times dx is 5 dx. Okay, now let me divide both sides by 5. When I do so, this 5 will cancel out. And this du over 5 can also be written as a 1 over 5 times du. On the right side, we get dx. Okay, now let me continue with the integration we have over here. So it is equal to 30 times integral 1 over 1 square positive. So for this 5x, we can plug in u. So we get u square. And for this dx, we can plug in 1 over 5 times du. Let me write it over here. Okay, now let me continue the problem over here. 30 times here, this is a part in the integrand which contains a variable, and this complete part is multiplied by the constant 1 over 5. In integrand, whenever a complete part which contains variable is multiplied by some constant, the constant can be moved out of the integration. So here we can move this constant 1 over 5 out of the integration. Then I'm getting 30 times 1 over 5 integral 1 over 1 square positive u square times du. So here 5 goes into 5 one time, so 5 goes into 30 6 times. So we get 6 times. So when I consider the integrand over here, it's exactly in this form, 1 over a square positive x square. Now we can use this formula to get integration of this stuff. Then I'm getting 6 times 1 over a. So instead of a, we have 1, because at the place of a square, we have 1 square. For a, we have 1 times arc tangent, okay, x over a. But at the place of x, we have u. So we have to write u, and at the place of a, again we have 1 positive c. I am adding constant of integration over here according to the instruction, because the integral is the indefinite integral. Whenever I evaluate indefinite integral, I must add the constant of integration. The question instructs we have to use c for constant of integration. That's what I'm doing. I've done over here. Okay, so here 1 over 1 is just 1. 1 times 6 is 6. Then arc tangent u over 1 is just u positive c. Actually, this variable u was taken by us. It has to be replaced by the original stuff 5x. Let me do it. 6 times arc tan of we can plug in 5x for this u. So 5x positive c. So this is the result of the given indefinite integral.